Hi everyone, welcome back to our channel. So today we will discuss very interesting problem that is pass the pillow. Even though it looks like easy problem, but it has its own interesting facts to discuss so that it will be useful for other problems in arrays. So let's see what is the problem statement here. So there are n people standing in a line labeled from 1 to n. The first person in the line is holding a pillow initially. Every second, the person holding the pillow passes it to next person standing in the line. Once the pillow reaches to the end of the line, the direction changes and the people continue to pass the pillow into opposite direction. So for example, once the pillow reaches to the end person, they pass it back to n minus 1, n minus 2 and so on, right? So given the two positive integers n and time, return the index of the person holding the pillow after time seconds. So the inputs are number of persons that is n and and the time that is t. Then we need to give the output of the index after the time seconds. So as you can see here, so it is kind of the cycle where it will start from person 1 to person 2 and person 3 person 4 person 5 person 6 person 7 and person 8. So once it reaches to end of the count, again it will come back again and it will do until the time seconds. So it is more of what you can see, the initial approach will come to our mind more of follow the direction in one way and try to increment the count, and once we hit the max value, then change the direction, right? It's more of the directional problem where increment with the positive direction and decrement with the other direction. So that is the approach we will take and see how that solve this particular problem statement. Let's dive into the approach and we will come to the final solution. Maybe we'll discuss couple of solutions in C sharp language. Okay, I think we discussed about the approach. Now we'll try to solve the problem with the direction as a kind of the positive when it goes to the going to the forward direction, and if it is coming back then it will be kind of the negative direction, right? So for that I will declare a variable which will capture the direction. Positive one means it is going forward, negative minus one means it's going backward direction, and the final result we want to capture is the position of the pillow, right? So for that I'll have variable as position one. So I will take the time loop where let's say t equal to 0 and t less than the time. So we will traverse till the time is available, and what and the position will be incremented, right? Incremented based on the direction. So right, so the position will be incremented based on the direction. So if the direction is positive, then it will be incremented. When if the direction is negative minus one, then it will be decremented. So the condition we need to have if the position equal to n means it reaches the end of the value, or if the position equal to 1 means starting of the starting person, right, in this case. So then the direction will be minus 1. So if it is going forward direction, it will become minus 1. Again, if you're going again from the backward, it going forward, then it will become positive. So direction, like we'll capture the direction based on the way it is moving, means the pillow is moving, and we'll assign the direction value. So the final result will be return position, right? Sorry, it's always declaring variable as I, so I think there is a mistake which I done here, but I think that should be fine. So the mistake which I done is it should be in the for loop, right? I don't know why it came out of the for loop. So that is the wrong. Right. So this is very straightforward. If you go ahead with the direction and capturing the position with the traversing with the time and updating the direction accordingly, will give the final position of the pillow. Thank you. Okay, let me go to the second approach. So I will go quickly around this one. So personally, I think I like the first approach. This one, it's good to understand the concept of the cycle of the cycle, like the cycle in the sense here. What I mean here is like kind of going from person one to n and coming back. Right, this is a complete circle. So I think this is good to understand. Good to understand. Having this concept ready will be useful. So let me go through this so that it will give you more idea, right? So imagine, right, you have n people standing in a line labeled from 1 to n. The first person is kind of initially holding a pillow. Every second the pillow is passing from one person to another person. Once the pillow reaches the end of the line, it changes the direction, continues back to the other way. So that is where the key concept cycle will come into picture here. So here, like, let's say to solve this problem, where we need to understand the complete cycle here. So the complete cycle is when the pillow goes from 1 to person n and coming back from person n to 1, right? So what it means, so it will take 2 into n minus 1 seconds, right? The total cycle length is 2 into n minus 1 second. So this is the example which I given. So if n equal to 5, right, it will go to 1 to 2, 2 to 3, 3 to 4, 4 to 5, again 5 to 4, 4 to 3, and 3 to 1, and 2 to 1. So it will take total, if it n equal to 5, then it will take 8 complete seconds, right? So that is the first thing, we'll calculate the cycle length. Then we will find the effective time within one cycle, right? So why we used modulus operator here to calculate the effective time, correct? So for that, let me go back and explain why we taking the modulus operator. So we use modulus operator to get the reminder when time is divided by the total cycle length, right? So let me take an example to explain this modulus operator, right? So let's say you have, suppose you have the cycle length of 8 seconds, right? You have 8 seconds and you want to know the position after 15 seconds. So 8 comma 15, right? Then the modulus operator 15 modulus 8 will be 7, right? So it means what exactly the 7 tells us, this is equivalent to 7 seconds into current cycle. So when we are going to the current cycle, that means it is 7 seconds. So because it is going, means it's not going through the complete 15 seconds, so the modulus operator will give the remaining 7 seconds into the current cycle, right? So that's what it will give here as a modulus operator, right? 8 modulus 15, sorry, 15 modulus 8 will give the 7, right? So we will use this one to see the effective time, right? Let's say in this case the 7. So if the effective time is less than n, means the pillow is still moving forward, means it is still going forward, means the effective time plus 1, means it will, the final position will be the effective time plus 1. Or if it is less, I mean if it is greater than n, means the pillow is moving backward, means, so that's why like, so for example, like if you want to explain this one, how the backward will come into this particular formula. So let's say for example n is 5, right, and the effective time is 6 seconds or 7 seconds. So let's say 6 seconds, right? So then it will be like, first we'll calculate effective time minus n minus 1. So it is effective time is 6 seconds, 6 minus 5 minus 1, 4 to 2, then n minus 2, so the total n 5 minus 2, 3. So at 6 second the pillow will be at the third person, right? So this is the formula we will capture in the backward direction, then this is the formula we'll use for forward direction. So that the total logic here will be kind of crucial to understand the cycle length and get the effective time, so that it will kind of remaining time at that particular current cycle to calculate the position of the pillow. So if you ask me personally, I will like the first approach, which is very straightforward, and but this also kind of give more understanding of how the cycle looks like and to derive the formula for the final position of the pillow. I hope you understand both the solutions, and see like what exactly fit for you. And I think, in my opinion, I'll go with the first approach, which is very straightforward, and as this is kind of mentioned as an easy problem. Thank Okay, now let's discuss about the time and space complexity. So as you can see, the time complexity will be order of time because the loop runs the time times, right? So initially, if you remember, the initial loop still runs up to the time as an input, and that's what the time complexity. So in this case, it will be order of time. So the space complexity, because we're not storing any extra memory or extra information, so it will be order of one because we're not storing any information. So when it comes to the similar problems, these are the similar problems which you can solve to understand more about the circular array, the loop detection, and also understand more about the direction of the array and more. So I hope this is helpful. Thank you so much.